In this video, I will show you a 2D high-speed dynamic core mill toolpath. 2D high-speed dynamic core mill utilizes the entire flute length of their cutting tools to produce the smoothest, most efficient tool motion for high-speed pocketing and core milling. The dynamic core toolpath machines open pocket shapes or standing core shapes using the outmost chain as the stock boundary. The tool moves freely outside of this area. The inner chain defines the limit of the toolpath. The first thing we will do is break lines prior to chaining. To do this, select Edit, Trim Break, Break two pieces. Select the following line as shown. Now indicate the break position. Select the following line endpoint where we want to break the line. Again, select the following line. Now pick the point as follows. You can now press the OK button to exit this command. From here, select Toolpaths, 2D High Speed, Dynamic Core. When the new NC Name dialog box appears, select the OK button to accept the name. When the chaining dialog box appears, leave the default settings as shown. Select the following rectangle. Now select the outer profile of the part as shown. The chain will stop at the break point. Pick the line past that point to continue the chain. You can now select the OK button to exit the chaining dialog box. Again, select the OK button to exit the Chain Options dialog box. In the Toolpath Type page, Dynamic Core Mill should already be selected. We will now choose a 1/2 inch flat end mill from the library and set the tool parameters. From the Tree View list, choose Tool. Now click on the Select Library Tool button and then choose the Filter button. Select None and then under Tool Types, choose the flat end mill icon. Under Tool Diameter, pick Equal and input a value of 0.5. Once complete, select the OK button to exit the Tool List filter. In the Tool Selection dialog box, you should now only see a 1/2 inch flat end mill. Select the 1/2 inch flat end mill and then choose the OK button. Your tool will appear as shown. Input the following comment. Machine the material surrounding the part using Dynamic Core Mill. Once the comment has been entered, select the cut parameters. Ensure the parameters appear as shown. Make sure that the amount of stock to leave on both the walls and floors is set to 0. Also, change the approach distance to 0.5. Change the percentage of tool diameter to 500. Before moving on, disable Optimize Cut Order within Pocket. From here, select the depth cuts. Ensure that this option is disabled. From here, select entry motion. Ensure that the entry method is set to helix only. Now input a Z clearance value of 0.05 and a plunge angle of 2 degrees. Finally, ensure that the helix radius value is 0.5. Finally, select the linking parameters. Enable clearance. Input a value of 1. Also, input a depth value of absolute -1. The rest of your parameters should appear as shown. You can now select the OK button to generate the toolpath. I will now show you how to check your parts using Backplot and Verify. To backplot the operation we have done so far, select the backplot icon in the Operations Manager. Backplotting shows the path the tools take to cut the part. This display lets you spot errors in the program before you machine the part. As you backplot toolpaths, Mastercam displays additional information such as the X, Y, and Z coordinates, the path length, the minimum and maximum coordinates, and the cycle time. It also shows any collisions between the workpiece and the tool. From here, select the Backplot tab and enable the following settings: All Operations, Follow, and Leads. You can now select the Home tab. From here, ensure that Tool and Workpiece are enabled. Finally, select the Play Simulation button to run your backplot. Your toolpath will appear as shown. Now we will simulate the toolpath and verify. From the Mastercam Backplot Home, select the Verify button as shown. Ensure that Tool, Stock, and Workpiece are enabled. Verify mode shows the path the tools take to cut the part with material removal. This display lets you spot errors in the program before you machine the part. As you verify toolpaths, Mastercam displays additional information such as the X, Y, and Z coordinates, the path length, the minimum and maximum coordinates, and the cycle time. It also shows any collisions between the workpiece and the tool. You can now select the Play Simulation button to run Verify. Your part will appear as shown up to this point. You can now exit Verify.